Okay, so it's 5 p.m. Ukrainian time, yeah, and I see more people to join us. Lewis, let's give them 2 more minutes to be ready. Yeah.
All good.
I know that we are also broadcasting to YouTube, so we'll see. Okay, 1 more minute, guys. Make a coffee, make a tea, just relax and be ready to enjoy it. Okay. So, Lewis, I think we can start. And I will take a moment to give a warm welcome to everyone who just joined us to our workshop, How to Create Contract Test from your End-to-End Test with Cypress. And I'm really glad to see each of you and everyone with you today. And I appreciate you guys joining us and our QA Symphony community. And while I'm here, I would like also take a moment and do a little bit advertising of our Symphony QA community, that a group of dynamic people that are passionate about our quality assurance. And we regularly actually bring in external speakers like Lewis and foster our internal growth and development within our team. And now I would like to introduce our fantastic speaker, Lewis. Lewis, as a QA lead in fast growth startup with over 9 years of experience in the field. He also has his own test automation course and a cool podcast on contract testing. And we're excited to have you, Lewis, here with us today. And thank you for sharing your expertise and insights with all of us. During this workshop, Lewis will be sharing some valuable resources with all of you guys that you can download and practice together with Lewis today. So sit back, relax, and let's dive in. Now, Lewis, the stage is yours. Welcome.
Thank you very much. I'm really glad to be here. It's really, really exciting. And I'm just going to share my screen, so you'll be able to see.
Yeah, before you share the screen, I would like just to make a comment. Guys, in case you have any questions, please use our chat for this. Write any questions, and in the end, we will discuss it and we'll answer all your questions. Now I'm mute, so Lewis, you go.
Brilliant. Hi, everyone. Thank you so much for coming to the workshop. So I'm Lewis Prescott, as mentioned. I'm the packed man, if you like, and I'm going to be talking to you about how you can create contracts from your end-to-end tests. So we'll talk a bit later about what challenges we had with end-to-end tests. There's a little bit of interaction to get ideas from the community, and also we will have a code along session. So there's a link in the chat where you can download the repo if you want to code along. And there's some prerequisites that you need to download. Don't worry about the Docker, but as long as you have Node.js and an IDE, you can work with me. So why are we talking about contract testing? So one of the articles that I like to promote is microservice being the new unit testing within. Contract testing being the new unit testing within microservices. Why is that? Because the popularity of microservices over the past years has become much more popular. So the red line in this graph is monoliths, and then the blue line is microservices. So as you can see, lots of more people are adopting it, and it's becoming kind of on par with monolith applications. And why is that important? Because you're separating out a lot of your components, which means you can test them in different ways and you can isolate your testing. So when we had traditional API testing against monoliths, what we were actually doing is we were hitting an API. The API would source the data from multiple domains and then return us an API response. This allowed us to check the service via, but we were actually hitting lots of things that we maybe didn't need to hit within that test. Be a lot of duplication across tests and things like this. So microservices was developed in order to isolate those domains and make sure that we were only returning data that the person actually cared about when querying that API response. This came about when like cloud providers were able to offer us cheaper ways to service our APIs. And so the benefit of this, right, is that we can isolate and we can put a specific test against our API service. But this means we've got lots of other integrations and lots of different interactions, which maybe makes the testing more complicated. So often when people are talking about contract testing and end-to-end testing in general, we get these kind of questions. So when you're developing an API service, how are people consuming it? How is the web client using it? How is the mobile client using it? Are there any differences between the two? And if I want to update this API, how would I go about doing that? You want to reduce your reliance on your end-to-end tests, for example, or your integration tests, because they're flaky, they run in a test environment, which is hard to maintain, and they're long-running tests. So contract testing offers solutions to that. And one of the big humps for people to get started with contract testing is that they don't know where to start. So hopefully by the end of this talk, you'll have an idea of how you get started with it. And this adapter that Packflow provided, which offers the ability to turn your existing tests into contracts, is a great way to get started. And something I'll address later in the talk, which is, does contract testing replace end-to-end testing? The short answer is no, but I'll explain a little bit later. So to help me with the talk and to help me understand where the audience is, can you go to menti.com or scan the QR code and enter the code below? There's a couple of questions that I want you to answer about your experience with contract testing and also your experience with end-to-end testing and any challenges you faced in that environment. Just going to jump to another window, but don't worry, the code will come back. Cool, it's good to see some beginners. So I'm going to go through the basics to start with. So hopefully offer some background to why we care about contracts. And then hopefully we've got some people who understand the benefits of it, but don't know how to implement it. And then I'll touch on that as well. Great, that's good to know. And then the second question that I'm asking about, we'll come back to that at the end of the talk. So if you just fill in the question, then I'll come back to it later. Great stuff. So explain a bit about my situation and why I wanted to think about using the bidirectional method of contract testing. So we have lots of end-to-end tests, which are dubbed end-to-end tests, but actually they're not end-to-end because we're mocking out and we're stubbing using Cypress all of the dependencies. So all the API requests are all stubbed out, and the login is actually implemented completely separately. We're mocking the token. So it doesn't reflect the production environment. And the mocks are static within our code. So if anything changes on the API, any nuances changes, then potentially our mocks will break, or they don't actually reflect what the production looks like, what we're actually, the response we're actually getting from the API. So that's the current situation. We've got a lot of tests, right? So we've got a lot of end-to-end tests. They take a long time to run in the pipeline. So we don't want to completely remove these tests. We want to utilize them, work with them to make them faster, to make them more robust, and to make sure that we are testing as lifelike as possible. So that comes on to the contract testing solution. So one of the another scenario where I've come across challenges before in working with APIs is we had a version 1 and a version 2 of the API. The legacy system used version 1, and then version 2 was used by our web app and our mobile app. Both shared a model within the code. So any change we made to the model was picked up by V1 and V2. So we noticed within our database that bad data was getting in there. There was some data missing, which we needed to stop. We needed to have that data in order to ensure compliance with things like GDPR. So we made sure that we updated the model. However, what we didn't realize was that the version 1 of the API was going to pick up that model and it was going to break the legacy solution. So the test that we had obviously got updated with the change that we made. So we updated the tests in both V1 and V2, so they passed. We were the API, so we had control over those tests. The legacy system had a 6-month release cycle. So any changes they needed to make weren't going to happen for a long time. So obviously the consequence was we had to roll back our change, and then V2, the version V2 didn't get the change either because it had been rolled back. So then we had to make the changes separately, duplicate 2 different models. V1 now had a deprecated model, V2 had the new model, and now we're supporting 2 different versions of the API base structure. And this could be all been prevented if we had contract tests, which the legacy system passed to us and we played those requests. Also, communication with the legacy system would have helped that solution. Another scenario which we had within our API was that the JSON structure, so any JSON response that we were sending, stripped out any null values. So any null values would just not get returned. The key and the value would both get stripped out because our assumption was that the nulls weren't important to people, right? What's the difference between not receiving the item and receiving a null value? Both are sending the same message that there is no data for that key. But what the situation was that the web application was using that null value to make some logic on the front end. So saying if this value is null, then render this object. If not, then don't render it. And so the assumption that we made that no one cares about this data was wrong. We needed to communicate with that team to say, are you relying on this data or not? Whether it's there or not, whether we have that data or not. So these kind of situations are, 1, solved by communication, which contract testing is fundamentally a communication tool. And 2, if we had contract tester, we'd know that the consumer needed that information. So what actually is a contract test? So Martin Fowler describes it as a test at the boundary of the extent external service. So if you think about like a component test, for example, or an integration test, which you traditionally talk about, which communicates with the service directly, we're stopping at the point where it's sending the request. So there's no actual message passed via HTTP or gRPC or any kind of communication method. All that's happening here is we are saying, this is what the request looks like, this is what the response looks like. And the way that I describe it, to put it a bit simpler, is that we've got an integration test, and what we're doing is we're flipping it upside down. So when you think about an integration test, you're thinking about the API service itself is sending a request, and they're the people that own the request. In contract testing, what we're saying is that the consumer owns the request. So the web app or the mobile app owns the request or another service, and they're saying, this is how we communicate with the API. Please give us the response how we would expect it. So you're changing the ownership of who owns the testing within the consumer, within the contract. And the tool that I've been using for many years to implement this is Pact. So Pact is an open source tool which allows you to implement your contract tests. And PactFlow is the software as a service which offers a solution to convert your existing tests into contracts. So what is happening, as Martin Fowler described, is the consumer is using a mock. So they are never actually communicating with the API service. What they're doing is they're saying, this is how my request looks like, and this is the response that I expect. And the mock returns that response. It creates your contract, and then the API service or the provider is replaying that request and saying, okay, here's what the request looks like from our consumer. Let's replay it against our system running locally. And then this is the actual response that we send in this scenario. And then it gets compared with what the consumer expects. And then everything should match up and everyone should be happy. So some of the benefits, right, as you can see from the diagram, are that it runs independently. Neither are dependent on each other. It gives you faster feedback because you're not relying on an environment to be available, apart from the one you have running locally. They're stable because they're using mocks, and they're easy to maintain. So they live right next to the code base. So anytime you make a change on the consumer side and it changed the request, then that will update the contract immediately. And then the API service, the provider, will pull down the latest version of the code, the consumer contract, and they will just replay that. So they don't have to make any changes on their side. They just point to the latest version. So I've been talking a lot about API services, but this is just to represent that it's also available for events. So if you've got an asynchronous messaging architecture, then the event object is your contract, and it's consumed in the same way, right? You publish the event, the consumer receives that event, and they need it to be in the right format and have the right data. So we still care about it in the event world as well. This is just to break down the terminology that I was explaining before. So the consumer is the person who makes the request, the web app, the API, another API service, or an event listener. They are the consumer. All the contracts are stored within a broker. So it's called the Pact broker in Pact, but they store all of the contracts and they tell you which ones are linked to each other, which services are consuming which API. And it gets complicated very quickly, as you can see. and then the provider. So the provider is the person, the team or the developer who is providing the service. So the API or the event, the person who is providing the response. And as I mentioned before, contract testing is as much a communication tool as it is a testing framework. So some of the instances that I've heard about, not all of these I've experienced, but so often we generate Swagger documentation from our code. So once the API has been developed, generate the Swagger documentation, we share that with the front end team, they go away and develop it as per the documentation, right? If there's any changes, then you update the Swagger and the loop goes on, right? So some teams create the Swagger documentation before implementation, and then you'll still get changes as you develop, because development is fluid, right? And you discover things as you're going along. So the Swagger documentation is a great way to communicate, and open API specs are a great way for people who have the common understanding to share that information. But at the same time, the feedback is coming late in the cycle. Someone told me this story, which I don't know whether it's true or not, but they seemed pretty pained by the experience. Is previously they've worked in environments where a Word document was passed around, and the name of the API spec would obviously change from like final v1, v1.11, and then you've got multiple documents flying around, which obviously in this day and age is not a viable solution. And then how my current employment work is we create Confluence documentation, which has our API specs in there. So when we make a change to it, we communicate to people that the Confluence page is updated. Please go and find the information there, which works well, but it's not live, right? We're still relying on humans updating, and humans make mistakes. Like, we're all human, we all make mistakes, and communication is very hard, often in distributed teams where you're working remotely, you're working in different regions, you're working across time zones. Communication becomes very challenging. And so, yeah, to kind of understand what the difference is between the integrations and tests and contracts, what I've put together here is an example of the different scenarios that you could use each of the types for. So as mentioned in the previous question, was like, can end-to-end tests replace, can contract tests replace our end-to-end tests? And ultimately the answer is no, because the integration still needs to test environment kind of level situations, and business logic should not be inside your contracts, because they should either be tested on the unit level, or if there's a specific integration scenario where you want to test, in this scenario, this happens and the front end displays in a different way, then obviously you'd need the integration for that. Contract tests are for looking at what you've defined in your API documentation, and also to make sure that if you make any updates to the responses, those are picked up before any breaking change happen and your environment goes down or production goes down. And often there's a comparison between schemas and contracts, but ultimately they are different in certain ways. I won't go into all of the differences, but contracts are doing a dynamic, if you like, validation of the consumer and the provider. A schema is something you're passing around, right, in a static way to enable to make sure that both parties are communicating with the same object types, but not all schemas include all of the kind of granularity that comes within a response. So there are similarities, absolutely, and you can do kind of schema-driven contract testing, where you just use your schemas to validate both sides. But yeah, if you want that kind of dynamic validation, verification, then you want to be using contracts. And Packflow posted an article on this to read about. And where does contract testing fit within your testing kind of strategy, if you like? I like the testing trophy, which Kenzie Dodds promotes, whereby you have lots of static analysis, you have a few unit tests, and you have lots of integration tests. But I've put contract testing in there instead of the integration level to say we want lots of contract tests to determine whether we're to offer that faster feedback as part of the integrations. And then we still have a few integration tests to check the environment kind of level stuff. And then we have just a few end-to-end journeys to make sure that all of those microservices that we were talking about before play nicely together. So now is the time to come back and see what experiences everyone has had with end-to-end tests. So yeah, these are the kind of topics that I want to come up. So the maintainability of end-to-end tests is high. So it's constantly a topic of conversation. How can we make them less fakely? They failed on the build. Why has that happened? Third-party APIs is a great one. Something we're not really going to touch upon today, but I did write a blog about it. Unstable environments, like environments are notoriously difficult to keep up to date unless you're doing proper CI/CD and spinning up and tearing down your environments, which not a lot of people do. Yeah, it's complicated. It is complicated. That's a great way to describe it. Brilliant. So these are some of the things that contract testing can absolutely address. So in the introduction, we talked about the fact that they are isolated, they are stable because they are using mocks. So what we're going to do in a minute is we're going to create our contracts from our end-to-end tests, which will mean that you can then, within that testing trophy, you can move some of the tests down into that layer. So this is where bidirectional contract testing comes in. So Packflow coined this term because basically what they are providing is the ability for you to create contracts from once you've implemented the code, right? So often you get to the point where you've got a legacy code base or you've got multiple integrations already and you want to implement contract testing. And before it was very a consumer-driven approach where the ideal situation was you have a greenfield project, you implement contract testing, happy days, you never have that tech debt. But bidirectional allows you to introduce the contracts after you've implemented the code. And so what does that mean? You get all of these benefits, right? You can test earlier because you can test before the environment. You get the increased confidence because you've got these verifications to say all of these integration points have been successfully verified. You've got visibility of who your consumers are and how they're using your APIs, and you've isolated the API contracts. So you can check those integrations in isolation without having to rely on an environment to be available. And what we're going to be looking at today is the left-hand side of this diagram. So the consumer side of things. So we've got our end-to-end tests, and we've got our mock, which we already have, and we want to turn that into a contract, because what we want to do is we want to pass that to the provider and say, here's a contract of how I'm interacting with you, and you can then use your open API specs that you've already got to verify that my contract conforms with how you've implemented the code. And they then don't have to introduce any additional code on their side. All they have to do is point to their open API spec, and Packflow does all the work of comparing the contract with the specification, and everyone's happy because there's no duplication of code. They don't have to rewrite all their tests, and we've got a contract. So we've got that confidence that we wanted. So Packflow offers multiple adapters. If you're using Mock Service Worker on your front end, WireMock, or Playwright, all these adapters exist, so you can generate your contracts if you've got any of those types of mocks or tests. And then the one, obviously, that we're going to be touching upon today is Cypress. So if you've managed to clone the repository, then feel free to follow along through that. Or if not, then yeah, just have a look at what's going on. So I created a very basic application. So Ed Sheeran's one of my favorite artists. He lives locally to me, so it's a great great example for this community. So I have this application where when I land on the page, I want to see Ed Sheeran's top 3 songs. So I click the Show Songs button, and it hits an API which returns these songs. Imagine I've implemented the database. I've got multiple artists. This is just a simple example for the demo. So this is the API, and this is Swagger documentation for this service. So I have this API that already exists, and in my end-to-end tests, I've mocked it out. So I'm going to stop the API service now, and I'm going to run my tests. So using the yarn site open, I should have increased the text size. So now we've got Cypress running. My front end application is still running in the background. And I have this test, which is just clicking on that button that I showed you, and it's returning me a list of songs. So I've got a stub set up for this API URL, and it's returning me a mock. So if we have a look at the code now, so this is my mock that I have within my Cypress tests. And as you can see, that's what was displayed within the tests. And that's what I've set up as my intercept within the Cypress test. So I intercept the request, and I wait for the API request and the intercept to happen. And then I can make sure that my button is displaying the songs. And so what I want to do is I want to convert this mock that I already have. So this fixture here, I want to convert that into a contract. So usually what you'd have to do is you'd have to create a pack test in order to generate the contract. Pact has its own language of how you would do that, and it takes time to set it up and understand the framework. So what we're going to do now is, in just a few clicks, we are going to create that contract from our existing test. So simply what we need to do is we're going to go to the Packflow Pack Cypress adapter documentation, which gives us an example of how we would do that. So as you can see, I've already got the intercept set up. So that step is already done. And I'm going to copy this into and the UI is for my songs web page, and my API is songs. So this is the consumer and this is the provider, and that's all we need to do to set up the pact. I've already installed the dependency, so I already have the dependency here, and I've already set up the plugin information. So the pack plugin exists within the end-to-end configuration, and there's commands are already added to the end-to-end support file. So I already have these available. So all I need to do within the test is set up the pact. And finally, what I need to do is, instead of using the sci.wait to intercept the songs, what I'm going to do is switch that out for the packed version. So we come in here and I'm going to substitute this. So as you can see, the function takes a list of strings and without the @ symbol. So that's all I need to do to set up the pact and wait for it so that it will generate me the contract. So if I just hit save on that and come back to my Cypress tests, so it's too fast. So we can see it's still setting up the stub, and it's reading the JSON file, which is now our contract, and it's writing that. So now we can jump back into our project and we can see that this file has been created. So what is this file? This file is a packed version of a contract. So what's happening in here is it's got our consumer and our provider, which we set up, and then it's set up this interaction. So what the interaction is it contains our request. So it's taken the description from our tests. So it's got this request. So this is what the test is doing behind the scenes, right? It's getting this API, and this is the one that I've intercepted. So it knows this is the one that we're talking about. And it's get request, so it doesn't have any of this information. And also this is the response. So it's taken this body information from our fixtures file and put that within the body. And then this is the information it's picked up from the headers. And it's got a status code 200. Obviously, you can have different status codes depending on the scenarios. And then pact is telling it that we created it via an adapter, so it knows that's the case. So we have this JSON file now. And what we want to do with the JSON file is we want to publish this to the pact broker. So in order to do that, I've already published one. So this isn't part of the code along, but we have pact provides a Docker image for publishing. So what we could do is just use the Docker image to publish our pact. So we're just pointing it to our folder Cypress, which contains our pacts, and then we're just publishing those to the broker. So simple as that. I've created this bat file for Windows as well. We just passed the token and we passed the version. And this has now published a new version of the contract to the broker. So if we come into PactFlow now, so this is our broker. Which stores all of our interactions. I called it something else, right? So I called it this, UI songs, API songs. So this is the consumer, right? So the consumer has published their version of the contract. And this is the interaction that was within the JSON file. Now we've created the contract, which is what we're going to stop at today. But so what the next steps are from the provider side are they now have access to this contract. So they can point to this contract via this broker, and then they can update the version of their API service. And they can say 0.02 of our service complies with 0.02 of your service. And then PactFlow will do the comparison and we'll get a verification tick here. I might have an example. So you'll get a tick here, which will say success, it's been verified. And so at this point, then the consumer within the pipeline would use the can I deploy service, and the can I deploy says, I want to compare this with this branch and this environment, and it will return your response to say whether you can deploy or not. So at the moment, no version exists. So the UI wouldn't be able to deploy because they don't know whether what they have built complies with the API service. So there's kind of a three-step approach. So the consumer creates the contract, the provider verifies the contract, and then we check within the can I deploy whether the two are compliant with each other. And to touch upon the branches and the environments, so the branches are obviously, if you're using Git flow or any kind of strategy like that, then you can tag it with the branch, and you can tag it with pull request branches. So you can even verify the contract before you complete your pull request. And the environments is really important because you'll probably have different versions in different environments. So you can always point your test to the production environment to make sure that you're not going to break anything in production. And also you will, in a real life scenario, you would have multiple contracts. So you would have a contract for an error scenario, say that no songs were available for a specific artist and that returned an empty list. Then you will want to have that as your contract to make sure that the API provides you with an empty list rather than returning a 404 response or something like that. So that's the end of the coding session. So just to recap what we've done. So if you're starting from scratch, you need to make sure that you have the adapter available within your project. You need to add the plugin to make sure that this is launched when Cypress is launched, and you need to have the support file with the Packflow adapter so that you have the available commands. Within your test, all you need to do is make sure that you set up the consumer and provider, intercept the request, and use the packed wait to make sure that it intercepts the request and creates you the contracts file. Once you've got the contracts file, you can use the Docker container to publish your contract to the broker. This would all be a part of your pipeline because you only want to publish contracts that have been committed. And once you've published it within the broker, then it's accessible to the other people involved, the other team, or whether that's the backend developer within your team, then they have that available and they can replay it on their side. So let me jump back to my slides. So I think we're at the point where I'm ready for any questions. So if anyone has any questions they'd like to ask, feel free to put them in the chat, or if you have any thoughts.
Yeah, guys, I'm here also. I have some questions. We are streaming here on and also in YouTube. So we have 3 questions. I can read them right now.
Perfect.
But in case you guys have any questions, you're welcome to write them in the chat or to just raise your hand. Yeah. Okay, let's go. Question number 1. Lewis, are you ready? So repository testing can be evaluated as integration test. In this case, what is the best approach for repository integration tests?
I'm not sure what a repository integration test is. So if someone wants to elaborate on that, that would be useful. Or maybe repeat the question first. Okay.
Repository testing can be evaluated as integration tests. This is the question mark.
Yeah.
Then, in this case, what is the best approach to repository integration tests?
Yeah, I don't know what that is. Need some explanation on that one.
Okay, then August, that question was from you. If you are still here with us, please give us a little bit more details what you are looking for. Anyway, we have 2 more questions from August. And the second one, in contract test, how can we test sync call between microservices?
Yeah, so if you've got multiple services, then you still have a consumer and a provider. So one person is consuming the service and the other person is providing the service. So you don't have to, there's 2 approaches that you can take. Either you use the traditional consumer-driven approach, where you implement the contract on the consumer side, and the provider then uses the packed framework to replay that request and verify it on their side. So what you need to set up from the provider side is you need to intercept again your implementation. So either you have the app running as part of your tests, and then you intercept it via the HTTP port, or you use middleware to kind of intercept that within your tests. So if you have microservices, you still have the situation where you need to pass the request between the two. So hopefully that explains that.
Okay, thank you so much for your answer. And we have one more question from August, and it's also regarding testing microservices communication. So if we create a mock server, would it be meaningful, because it mostly seems expecting the values which already known?
Yeah, it's a good question. So if you're using existing mocks, right, like how I just demonstrated, the meaning of the contract or the mock in this instance, it comes from the verification process. So if your mock is not valid, then the verification will fail. So in the pack broker, you'll get a big cross, which will say that the contract is not valid. And this is because potentially the mock is out of date, or the mock does not reflect how the response actually should be. And at this point, it's about sparking conversation, right? So maybe the mock is valid and you want the API to change how they respond. And so you have the communication. Or maybe the API says, that's not a valid response, you need to change your mock. And then you change your mock, it changes the contract, you publish a new version, and then the verification goes green. So hopefully that answers that one.
Good. Thank you so much. If there are more additional questions, guys, welcome. Meanwhile, we got the explanation for the first question. That was
Perfect.
So for the testing database transaction process, what should be the best approach?
Okay.
Can be named as integration test? If yes, how should we handle database transaction tests?
Absolutely. Okay, databases makes sense. So contracts, as I described in the scenarios of integrations and contracts, databases fall into the integration part. So you can still have a contract between your how you're interacting with your databases, but that's not part of the contract, because that's usually part of the same provider. So the provider is the one that is communicating with the database, or if it's shared database or whatever, usually you have frameworks, like we have entity framework, which does the communication between the two. So they fall into integration tests because they are two components which you want to check integrate successfully. And yeah, contracts fall into the HTTP event world, where you're communicating as part of a request-based thing rather than a database-based thing.
Okay, thank you. And we have one more question. It's addition to the first question, which was about microservices communication. So there is additional question to this. What it needs, so would it need an extra effort to keep update API definition and mock definition? If we think about more than 100 services, how can we manage this?
Yeah, absolutely. So yeah, the idea, right, is that if you use existing mocks, then the effort is reduced a bit. If you have lots of services, then hopefully there's lots of people involved in maintaining those services. So you can split the load between the teams. And ultimately, what we're trying to do is we're trying to reduce the amount of effort that we have on the maintenance of our end-to-end tests. We're trying to develop software which doesn't cause integration issues, which doesn't cause our environments to break and stop development. So what we're trying to do is we're trying to reduce the amount of friction that we have on our environments with this method. So it's obviously you have to compare the weight of your maintenance efforts with introducing this this mock-driven approach. But yeah, this method also scales in terms of, because you have no you don't need to spin up multiple instances. It just runs as part of your unit test, so you can run these in parallel with all your other tests. And because you are using mocks, this can scale massively within your continuous integration pipeline, which end-to-end tests just can't scale at that rate, because in order to run tests in parallel, you would need to spin up new instances or put them in lots of Docker containers, and then you need bigger images. And the scaling factor is just larger with end-to-end tests and integration tests. So yeah, the idea of the contract testing solution is, yes, there is effort in maintaining your mocks, in maintaining the kind of verification of those, but it scales.
Okay, as far as I understand, this is the end of their answer to this question. I see no more questions for now. August, you are our big fan in terms of asking.
Really good questions. Really
yes,
good questions.
Yeah, that's true. That's true. Perfect, guys. 1 more minute. If anyone has any question, please just either raise your hand, talk, or just write it. Meanwhile, we also received a question regarding if we're going to have recorded the session. Yeah, the session is recorded, and you will be able to find it on our YouTube, Symphony Solutions, together with other interesting topics there. Good. Lewis, it seems that we're good for now. Thank you so much for your presentation. Thank you so much for your time and workshop. I'm sure. Oh, sorry. Meanwhile, I was talking and I see. Oh, no. Yeah. I see this other people starting to write thank you and to just share it, all this. Yeah. So thank you so much again for your time. Thank you for this wonderful presentation and for sharing your insight and experience. I would like to one more time say that with us was our fantastic speaker, Lewis, one that has a lot of experience in contract testing, who shared it all with us. Thank you so much. And guys, thank you all for being with us all this hour. Be in touch. I wish you all to have a great day.
Thank you so much.
Yeah. Thank you. Bye-bye.
Bye.